Hey everyone, and welcome to today's Explainer. If you are stepping into the world of programming for the very first time, you are in exactly the right place. I am absolutely thrilled to guide you through this, because we're looking at something that is literally the bedrock of all software. We're going to demystify a concept that might sound super technical at first, but it's actually something you interact with every single day without even realizing it. We are talking about programming variables. So let's dive right in and see how this one simple concept essentially makes all of modern technology possible. To start off, I want you to picture a truly frustrating scenario. Imagine you go to log into Facebook. You type in your username, you hit enter, the page loads, and then it immediately asks you who you are again. The app literally couldn't remember your name a single second after you logged in. Imagine trying to scroll through your feed, but the system just keeps forgetting who your friends are, or what a post even said the exact moment it tries to display it. I mean, it sounds completely impossible and utterly exhaustingly broken, right? Or hey, how about this one? You're using an online shopping app. You find the perfect pair of shoes, you click add to cart, and you keep browsing. A minute later, you go to checkout and your cart is completely empty. The app just forgot. Now, unless you really enjoy extreme window shopping, that's a broken system. The whole reason computers and apps can actually remember your information, your friends, and your shopping carts is because of the concept we're unpacking today. We are solving the problem of the amnesiac computer. So here is our roadmap for today's Explainer. We'll start with why computers need memory, the labeled box analogy, how variables actually work, variables in everyday apps, and finally, some common beginner mistakes. Let's kick things off with Section 1, why computers need memory. All right, so here is the formal definition, the real hero of our story today. A variable is a named storage location in a computer's memory that holds information. Now, since we're looking at this from an absolute beginner's perspective, please do not let the technical jargon intimidate you. Simply put, a variable is just a container. It's a temporary space that a computer uses to store data while a program is actually running, just so that it can be used or changed later. Without these containers, like we saw in our opening examples, the computer would just instantly forget everything it was doing. To really cement this idea in our minds, let's move right into Section 2, the labeled box analogy. Imagine you're moving into a brand new house. You packed up your entire life into dozens of perfectly identical cardboard storage boxes. Now, if you didn't write anything on the outside of those boxes, what happens when you need to find a frying pan? Well, you'd have to tear open every single box one by one, digging through clothes and books until you finally stumble upon the kitchen stuff. But if you just take a marker and write clothes on one box, books on another, and kitchen on a third, you've completely solved the problem. Instead of opening every box, you simply read the label. And you know what? Programming variables work exactly the same way. Notice the absolute stark contrast in efficiency here. A computer is constantly handling thousands, if not millions, of totally random data every given second. If it had to search blindly through all that data every single time it needed to know your username, your phone would freeze up instantly. By using variables, by placing data into these labeled containers, the computer doesn't even have to search. It just instantly reads the label and grabs the data inside. You can even visualize your computer's memory as a giant physical filing cabinet full of drawers. Each drawer has a specific label right on the outside. One drawer's label says name, and inside that drawer is the actual data, Lloyd. Another drawer is labeled age, and inside is the number 25. Another is labeled score, holding the number 98. Whenever the program you're running needs to know the user's name, it doesn't panic. It just walks over to the cabinet, opens the drawer labeled name, and pulls out Lloyd. The variable name tells the computer exactly where the information is stored. Let's shift gears now to Section 3, how variables actually work. So the really crucial point here is right there in the name itself, variable. It means the value inside the box can vary. It can change. Imagine you're playing a video game. When you first start, in step 1, the computer creates a variable, a box, labeled score, and it drops a 0 inside it. In step 2, you defeat an enemy and earn some points. The computer doesn't create a brand new box. No, it goes to the existing score box, takes out the 0, and puts in a 100. In step 3, you earn even more points, and it updates that exact same box to 250. The label on the box, the variable name, stays exactly the same, but the information inside changes as the program runs. Now, if you want to build really good coding habits early on, you have to use clear labels. Just look at the difference here. If you label your boxes with things like X, A, or temp, literally anyone reading your code, including yourself 2 weeks from now, is going to be incredibly confused. Is A the age, the total amount? We have absolutely no idea. But if you use descriptive names like student name, total price, or temperature, your code instantly becomes readable. Clear labels make it painfully obvious what kind of data is supposed to be in that container. Let's take this theory and apply it to the real world in Section 4, variables in everyday apps. Literally every app on your phone uses thousands of variables behind the scenes. Think about a food delivery app. To make that seamless experience happen, the app is constantly managing variables like restaurant, delivery address, current location, order status, and estimated arrival time. Or think about your banking app. It relies entirely on variables to store your balance, account number, transfer amount, and transaction status. If those labeled boxes didn't exist, the bank wouldn't even know whose money it was holding, and you certainly wouldn't want them just guessing your balance, right? Even the absolute simplest tools rely on this. When you open up a basic calculator and type 25 plus 17, the calculator app instantly creates variables. It might assign number 1 to hold 25 and number 2 to hold 17. When you hit equals, it creates a result variable to hold 42. Without these temporary storage boxes, the calculator couldn't even remember the first number you typed by the time you press the plus symbol. For our final section today, Section 5, Common Beginner Mistakes. It is totally normal to have a few misconceptions when you're first starting out. For instance, you might think these storage boxes are permanent, but in reality, a lot of them only exist while the program is actively running. Now, we already know to avoid confusing names like X, but another really huge trap is assuming these boxes can only hold numbers. And finally, never forget our video game score example. The entire magic of a variable is that its contents are actually meant to change. Let's look a little closer at that idea of storing more than just numbers. Variables are incredibly flexible. They aren't just for math, not at all. They can store text, like the name Lloyd. They can store true or false states, like a variable called isStudent being set to true. They can even store really complex collections of data, like a shopping cart variable holding an entire list of different products, prices, and quantities all at once. So we firmly established that variables are the labeled boxes that make our digital world possible. They allow programs to remember and manage data on the fly. But here is a thought to leave you with. We know they can hold different types of information, but what happens if a computer is expecting a number to do some math and it reaches into a box and pulls out a word instead? What actually happens if you put the wrong type of data into the box? Well, that is a fantastic question, and it's exactly what we'll be exploring next time when we dive into data types. Thank you so much for joining me for this explainer. I hope this foundational concept is now crystal clear for you. Keep learning, and I'll catch you in the next one.